Here's your video on the introduction to organic molecules with the subheading of carbohydrates. But before we begin, let's talk about the objectives or what we hope to learn from this video. First, we hope to learn about the properties of carbon and why they're so important to all living organisms. Then, hopefully you'll be able to determine the difference between a monomer and a polymer. I gave you a picture. Could you tell me something was a monomer or a polymer? Then I'd like you to be able to tell me the function of carbohydrates. In other words, what do they do for living things? Can you give me an example of a monosaccharide, a disaccharide, and a polysaccharide? Would you be able to draw a monosaccharide, disaccharide, and a polysaccharide? And lastly, can you tell me the difference or relationship that they share between those three types of saccharides? So, let's begin. If we start by looking at a whole bunch of different molecules here in your slide, we're going to tell a little bit about each one. So let's look and see what they have. If you look at the first one, it's got carbon, oxygen, and hydrogen. The second molecule here has carbon, hydrogen, and nitrogen, and also oxygen. This one has a bunch of carbons in a long chain with a bunch of H's and OH's. This is very similar to that one, but it's got three of those chains all linked together. This one's a little bit different than the previous one, but it has three long chains of carbons coming off of it, but this one is a little bit bent. And this gigantic molecule is totally different than all the rest. It has a nitrogen base, it's got a funny little pentagon here, with attached to a phosphorus group. All of these contain most of the the elements of life. Carbon, hydrogen, nitrogen, oxygen, phosphorus. And the only element here we're missing is sulfur. So we will have compounds that have those in it later. Let's also kind of look at what's the big main central element here. If we look at this, carbon seems to be used to build everything else off of it. Carbon here along these long lines. Carbon, 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 carbon in this chain, this chain, this chain. Go over this one, you've got a central carbon here. Each one of these have long chains of carbon. And in this molecule here, this little shape here, each one of these points would have a carbon if we wanted to draw it in. So carbon seems to be the central element here. And that's very important, and that makes carbon very important because it's a central atom that can be used to make four types of bonds. Now let's look at those bonds. Single bond, double bond. So we know that carbon can make more than one type of bond. It can make single bonds, triple bonds, double bonds, and those bonds as a result of that can make many different shapes. You can make a ring, a linear, nice long chains, and create something that almost looks like an E here. So those are key points to what makes carbon so important. It can share its electrons with four different atoms, different elements, and make all sorts of different types of bonds. Therefore, we call anything that's carbon-based an organic molecule. All living things are made up of organic molecules. Hence, all living things are made up of carbon. And that's why it's such an important molecule for biological processes. It can make different types of bonds, single, double, triple. It can form bonds with many different elements, oxygen, hydrogen, nitrogen, phosphorus. And it can make different shapes as a result of the different types of bonds. It can make rings, chains, and complex compounds. All of those reasons make carbon special. And that's very vital to all living things because life depends on other living things to survive. Let's look at then how organic molecules can be grouped into four different types. So, you can be a carbohydrate, a protein, a lipid, which you guys know as fats or nucleic acids. Those should sound slightly familiar to you because you guys know as your diet you have to have a certain amount of carbohydrates, a certain amount of proteins, and a certain amount of lipids. You don't hear about nucleic acids, but you eat them all the time. It's just they don't do anything for you. So the federal government regulates or tells you how many carbohydrates you should eat, how many proteins you should eat, and how many lipids. That's because you're basically made up of those and you have to constantly replenish them. So those are the four basic types of organic molecules. We're going to be coming back to those quite a bit this year. So when we want to build organic molecules, we want to start from the small ones and put a bunch of the small ones together to form larger ones. And we know that we're going to call the simplest or the smallest one a monomer. Mono meaning one, mer meaning molecule. So a monomer is one or the smallest molecule of that particular type. Polymers, however, or poly meaning many, are many molecules linked together. So it's a whole bunch of small ones linked together by a particular bond. In most of our cases, remember, we could talk about a covalent bond, a hydrogen bond, or an ionic bond. In all of our carbohydrates and the ones we're mostly going to be dealing with, you can assume it's going to be a covalent bond. So monomers are small molecules, polymers, small molecules linked together to form a larger molecule. So what do we need to know then about carbohydrates? Well, you guys eat carbohydrates on a regular basis. What do they do for you and what do they do for other living organisms is that they provide short-term energy. Come in these shapes, they have lots of little bonds, and as those bonds are broken, they're going to release energy that we utilize to supply us with energy. Things like muscle movement, ability to breathe in and out, our heart to beat, nervous system, messages to be sent, all those good things. You notice too, if you look at this typical picture here, our carbohydrates, it is only made up of carbon, hydrogen, and oxygen. And that's a hint that you're working with a carbohydrate, because you're going to have to learn how to distinguish between the 4 different types of organic molecules. Carbohydrates only have carbon, hydrogen, and oxygen. The other hint that this is a carbohydrate is its shape. It's hexagonal. Carbohydrates are always in a hexagonal shape. So when you're looking at a complex molecule, you've got to first ask yourself what elements are in it and what shape it is. And that's going to tell you what it does. And in that sense that this shape and these elements give us short-term energy. So for example, if you were to have a pasta or a bread or even one of those drinks like Gatorade or Red Bull, there's going to supply enough energy in those bonds to about 15 minutes or to an hour. After that, you start to slow down and not feel so good anymore, and you need some more energy. So just to recap, remember, good examples of carbohydrates are bread, fruits, and pasta. So let's move on to our monomers and our polymers of carbohydrates. Monomers would be your monosaccharide, or one sugar. Saccharide is the big fancy word for carbohydrate. Examples are glucose and fructose. Now also, try and remember and pay close attention to the endings of words, because that's going to give you a hint of what type of organic molecule it is. All words that end in OSE are sugars, and therefore they're carbohydrates. So you have monosaccharides would include glucose and fructose, while our polysaccharides are going to be a little bit more complicated. They're going to be disaccharides and polysaccharides. Disaccharides, like the prefixes, that means 2 sugars together, and that would include sucrose and maltose. Sucrose is regular table sugar that you sprinkle on things to make them flavorful. Maltose is another type of sugar that's in more complex drinks. Polysaccharides are also an example of a polymer, and they include things like starch, glycogen, and cellulose. Starch are things that's a complex carbohydrate that you found in potatoes. Cellulose is a complex carbohydrate that you find in plants, and it makes up plant walls. Excellent example of cellulose would be celery. If you've ever eaten celery, you know it's kind of stringy and rough, and that's the fibers that are in cellulose, and they're very important to humans for their digestive tract. Your doctors are going to always be telling you, oh, you need more fiber. And that's because it helps your digestive system move all of your foods along the digestive tract, and they're very important. So if you notice, here's a picture of a starch, cellulose, and glycagon, and they are long chains of glucose all added together. So they're a monomer plus a monomer plus a monomer plus a monomer plus a monomer. All of these, then if you take more than 2 monomers added together, you have a polymer. So this would be a single strand. 2 of them would be a disaccharide, and 3 of them are a polysaccharide. And this is an example of starch, cellulose, and glycagon. They're very complex carbohydrates. So what do we have to do here in this video? You have to take down your notes. Remember, the left-hand side is full of your notes, and the right-hand side is full of your notes, and the left-hand side is where you're going to put your key points in your vocabulary. Make sure you know these key vocabulary. What is a carbohydrate? Remember, it's an organic molecule that gives us short-term energy. What's a monomer, a polymer, a monosaccharide, disaccharide, polysaccharide? What do you know about sucrose, fructose, glucose, and cellulose? All key words that we're going to be coming to and referring to are going to be questions about, so you need to know what they mean. Can you tell me the importance of carbon? What's the difference between monomers and polymers? How are polymers put together and taken apart? Oops, you know what? That one's in there and you guys don't need to know that. Sorry, I'm going to take that right out next time. What are carbohydrates? What are their functions, their elements that involve them, their shape, and examples? So, for example, could you fill in this chart? Could you tell me the function of carbohydrates, the elements that make it up, the shape of carbohydrates? Could you tell me 2 examples of monomers? Could you give me 3 examples of polymers? If you can do all those things, or at least have them all in your notes, you know you did a good job. Don't forget, you also have to include in your notes a summary. So your right side has all your notes, the left side has the key points in the vocabulary, and down below at the bottom of the notes you're doing a summary. All right, see you in class tomorrow.